Hello guys, welcome back here, and in this video we are going to talk about the class diagram in StarUML using StarUML ID. Okay, the previous video we have talked about, or we have discussed about the use case diagram. So in this video we are going to discuss about the class diagram. Okay, this class diagram is more powerful in representing the software classes. Okay, all the classes that have been used to the programmers and as well as the clients. Okay, so basically there are six type of relationships in this class diagram. They are association, inheritance, realization and implementation, dependency, aggregation and composition. Okay, as you can see in this in the left corner of the screen, simple line or a simple straight line is association, and a simple straight line with the arrow mark is direct association, and this is aggregation, composition and generalization. Okay, dependency, realization. Okay, in the previous video I have discussed about the difference between generalization and the specification. So I hope there's no need of explaining the same stuff in this video. So I'm going to explain the other stuffs in this video. First of all, association. This association is nothing but which just shows the relationship between two classes, or how the two classes is in a relation. Okay, and this direct association is just the same, and you can see this this thing 1 plus, and here it's 1 plus dot dot, that is it's a closure. Okay, so you may wondering that what is this all about. It's nothing but it's the cardinality. Okay, so what is the cardinality? It's nothing but there are four types of cardinality: one to one, one to many, many to many and many to one. So this is nothing but one to many. So it's just a cardinality, so nothing to worry about that. So now let's talk about the aggregation and the composition. So what is the aggregation and the composition? This aggregation and composition is always lies between the two classes, that is the parent class and the child class. This aggregation is nothing but in this aggregation the child class can be independent without the parent class. Okay, but in the composition the child class cannot be independent without the parent class, and because of this the composition is much more stronger than the aggregation, but the aggregation is weaker than the composition. Okay, now as we have explained the most of it, let's go into this program, or let's go into this diagram. There are nearly some classes called bank, customer, teller, account, security and savings, and finally there's a class called loan. Okay, so inside the bank there are some functions, that is the bank ID. All these things are the things which we are going to use in this class called bank. And inside the customers, these are nothing but these are just a declaration, and here is the function. Okay, all these functions will be used in the class called customer, and these are the data members which have been used in this program, or in this class called customer. Okay, for example, let's take this class teller, or for a simple explanation, let's take a class called security. In this security there are two main functions called check function and monitor function, and there are three data members called employee name, employee ID, approval. Because in a class called security there will be an employee, and the employee consists of three objects called employee name, employee ID and approval. These are there which are being present in the class. Okay, and these are nothing but this is the realization. Okay, this arrow mark differs from this arrow mark, right? So because this is called direct association and this is called realization. This realization arrows always falls on the class which is common for two or more classes. Okay guys, that's all about this video. That's all about this video for class diagram. Thank you.